Hello, everyone. Assalamu alaikum. Thank you for all of those who are showing up today. Thank you again, Mr. Ahmed, for being here with us. As BNA trying to answer your question, today's presentation or webinar, it's all about the energy mix challenges and the future of oil and gas. So as usual, I would like to go over a few items. Because all of you will be in attendee listen only mode, just drop all your questions in the chat box, which will be answered in the Q&A by our presenter. And let me just give a quick overview about Mr. Ahmed. Mr. Ahmed is a senior engineer, petroleum engineer with over 20 years of experience in oil and gas, production optimization, and digital oil field solution. He currently holds the position of a product champion for the multi-phase below Schlumberger PIPESIM in Schlumberger, Norway. Mr. Ahmed worked with the Saudi Aramco for over 15 years as a technical consultant. And Mr. Ahmed holds a master's degree in petroleum engineering from King Fahd University in Saudi Arabia. Also, Mr. Ahmed published various SPE papers and participated in numerous training webinars for academia and oil and gas industry. So that's all for me, Mr. Ahmed. You may start your presentation.
Thank you, Asma, and good evening and maybe good afternoon, ladies and gentlemen. And it's really an honor for me to participate in this webinar, talking about a very important topic. I think most of the oil and gas professionals, especially the young engineers who are probably fresh graduates or about to graduate, they are concerned and worried about the future of oil and gas industry. We all hear and read the news about trying to eliminate the hydrocarbon and the fossil fuels from the energy as an energy resource, trying to invest more in renewable energy and so on. Many companies are putting targets to make zero emissions by 2050. All that is creating, I would say, some kind of worry, some kind of concern and uncertainty about the future of the oil and gas business and what will happen to us as petroleum engineers. And this is basically the main, I would say, subject, the main objective of this presentation or webinar today. I'd like also to talk about why the energy transition is a challenge and why the different energy resources, the renewable energy resources, are not catching up easily to become really the major I would say oil and gas resource, energy resource among the energy mix. So without further ado, let's start talking about energy itself. Okay, why we need energy, why the human being need energy, and the relationship between humans and energy is very, very far away. It goes all the way up to the caveman who actually burned wood to have warmth and to cook the food. Okay, so this was really the first form of energy that the human being used or interacted with. It's the fire. Okay, and obviously with time, as the human being invented new ways of making life easier, the relationship with energy start to also be more complex, and the human beings start to invent more and more ways to produce and consume energy. Okay, so people think sometimes that the renewable energy is something new, that everybody now is talking about renewable energy, but in reality, the first energy machines were actually renewable energy machines. We're looking at here a schematic of one of the early machines. This is a water-driven Roman Hierapolis stone mill from the 3rd century, imagine. So it's basically using the water, energy, the water force to rotate a gear, and then this gear was used to actually cut stone, okay? We have other examples, like for example, in the 14th century, we have this is called Norse Mill, and also it used the water flow as energy, and then this rotated some kind of vanes or impellers, and it was used for wheat grinding and so on. With time also, human beings start to interact with wind and manage to capture the wind energy. Nowadays, everybody's talking about wind energy, right? Well, it's not new. Wind energy has been there for many, many years. And what we're looking at is a picture of a windmill that was actually invented in the 16th century, okay? This is basically similar to the wind impellers or wind fans that we see today, but now they are actually 4 now in this picture, but nowadays there are 3. But also it was also used for mainly grinding wheat and other grains. Also, the human beings start to use animals in creating energy to, for example, to carry out water. And with time, we will start to have now more modern, use of the renewable energy. In this picture, if you can see right now, we see this river that has this wheel. This wheel actually rotates, and then we start to see to become seeing complex machinery. In which they start to be used in further industries, okay? And now look into this picture, for example, in the 1770s, we have a water-powered textile mill, okay? So now the energy that was coming from water was actually becoming, introduced into more complex machinery. And then we have a shaft now that is rotating vertically, and then the movement is actually, transferred into more complex machines, okay? All that is renewable energy. And until the 1800s, there was no real use of I would say, hydrocarbon, fossil fuels, in terms of energy, because the machinery was not invented in a complex matter so that it can get use of these I would say forms of energy. So all that is actually to capture energy from renewable resources. However, human being also generated energy. So there's a very good example of one of the very old machines of the hero of Alexandria, who invented this rotary toy, I would say, where basically he has a water tank here. He boils the water, and then this a wheel or this ball will start to rotate, okay? And this was actually the first invention that, that converted heat into rotational motion, okay? With that, engineers start to make it more complex. So now, and in the early 70s, in the 17th century or 18th century, we can start having, the new forms of steam machines, okay? This is, for example, a dual cylinder machine. It's called Jacobs Leopold steam engine, okay? And then we have also James Watt's pumping engine. So all of these two machines are now using steam. So now, instead of using only water flow, we are now converted. We start to convert. We burn coal or you know, any other form of fire. We boil the water, and then we take the steam and use it in kind of form of movable part. And this actually was a breakthrough because since the 18th century, since the 1750, 1720, all the inventions start to come into picture, and then different forms of industry start to exist. What we're looking at here is really the explosion of the machinery or the industries that we see until today. Look into this beautiful machine here. This is the Cognot steam wagon of 1769. So this is a machine that is actually, it's a steam car. Imagine. So there is a water boiler that would you know, use steam to move this car. Okay. This is also a machine in 1805 that actually it's a boat and a car in the same time. You see. And then we have also, this is a picture of a Roper steam car in 1860. And now this is also a beautiful picture of another steam powered vehicles, okay? Now, with that, as I said, this was the birth of the modern industry that we know today. Then engineers around the world start to build factories, okay? So during the second half of the 19th century, characterized by the introduction of steam power, okay? Separate buildings housed the steam engine, chimneys, stacked and water tanks were constructed, and belts and shafts were moved to the exterior of the building. So what we can look at right now here, let me just move my picture a little bit. So we have this nice factory here, and then we have steam boilers, all right? These steam boilers are used to actually rotate this big wheel, and this big wheel was actually moving belts inside the factory, okay? This is also a very beautiful picture of very long, you know, shaft that has wheels and that has gears, and these gears were actually moving machines, and then this became you know, new modern of generating of making actually products such as paper, such as textiles and cloth and so on. There is, in the same time, the advances in iron and steel alloyed made the factories to expand significantly. And in late 1860s, factories moved into designated factory zones. Many older factories located along the waterway were updated to steam power, okay? So now we are now witnessing what we call the Industrial Revolution, okay? During the same period, the electric bulb was also invented, okay? So the light bulb was independently invented by both Thomas Edison and Joseph Swan in the late 1870s, okay? Imagine with all the factories being built around the world using steam, using coal or mainly, all right? Also the light bulb was also invented. And now the term of electricity came to picture. And then initially, you know, what we're looking at here is the Edison Pearl Street station, okay? In 1881, Edison built electricity generating station at Pearl Street in Manhattan and Holborn in London. So what we're looking at here is the first form of electrical power plant, in which machines that are operated by steam and coal would rotate to generate electricity, and then electricity will start to be transmitted through cables, okay? And then, of course, in the beginning, it was only for the light bulb that will you know, light the houses during night. And this by itself was a major, I would say, major invention to the whole world, okay? Everywhere now and around the world, you know, within the coming 10, 20, 30 years, these stations were actually built to generate electricity. At the same time, we witnessed also the internal combustion engine. And this was the birth of the petroleum industry, okay? As you can see here, almost in the same 100-year, all right? In 1860, we can look into what is called the Lenoir engine. Lenoir engine is the first internal combustion engine. So now we don't need anymore a coal and steam. We can use the petroleum product to be burned, and then it will create moving part. All right. This is also a picture of the Otto engine in 1880s. Okay. And then we start to see, in 1885, the Daimlers Petroleum right wagon. So this is basically a bicycle that will run or using petroleum. And at that time, it wasn't really the thick oil, but because in the US, most of the reservoirs are shallow, so you would see that there are some kind of lakes of petroleum products that were used in basically burn to be burned, and then these engines would start to rotate. Okay. So all that, as I mentioned in the past few slides, will summarize what we call the Industrial Revolution. Okay. This started in the mid of the 1700 until the 20th century, which is 1900. Okay. This period, 150 years, there were inventions all around the world. Okay. We witnessed the migration from hand to machines, substantial increase in need for energy, rise of mechanized factory systems, and development of modern transportation system. Of course, this led to unprecedented rise in the rate of population growth, because now the food industries also came to picture. People were having a better life. So population growth, and in addition, as you can imagine, the pollution rate start to increase. And then also, this was also accompanied with the start in the rise of the global temperature. And this is what I will be talking about right now. So the rise of carbon emissions, CO2, and the global temperature increase started really to become significantly higher in a higher rate during this period. Okay. And then it will continue in the coming years. In the Industrial Revolution, we start to see a lot of new industries, such as light, as I said, the light bulb, the glass, paper, chemicals, food, mining, transportation, cement, steel, literally everywhere. So it was like, the world before the 18th century became completely different in the coming 200 years, okay? People start to build machines, people start to build cars, trains, etc., etc. And then with that, each of these industries were integrated, were interrelated. The industry of steel, the mechanical engineering, as we call it today, where it was really how to form a gear, how to form a shaft, etc., etc. All that was needed. So the whole world actually participated. Almost, of course, the whole world participated in this huge revolution. As I said, during this period, all that is driven by what? What do you see in the middle here? It's all driven by energy. Okay, to make all this happen, all these industries, to make the man able of doing all these, of course, without energy, none of this could have happened. Okay, and that will lead us to start talking about the global energy resources. Historically, without any doubt, okay, and without any debate, coal is the most important energy resource on Earth. It has been serving the humanity with energy since thousands of years, okay? So coal mining goes back thousands of years. Initially, the coal was mainly used for heating houses, for warmth, for cooking, okay? Later on, it was used to generate electricity as it converts into steam, as it boils steam. And then it was also used to move the trains, etc. It became essential during the Industrial Revolution to power steam engines, heat buildings, and generate electricity. Coal provided the main source of primary energy for industry and transportation from the 18th century until the 1950s, okay? By 210, this is very, very interesting fact. By 2010, coal produced over 1/4 of the world energy in the history. So this is really, really significant. In the beginning of, I would say I want really everyone from my colleagues and everyone who's listening to us, imagine someone working in the coal mining business, right? In the, let's say, 19th century, right? And of course, coal was the main, as I said, energy resource. And then this person start to hear that, well, there is oil that's being invented, all right? And oil now can be cleaner, can be easily transported, and it will need smaller machines. Then naturally, anybody who is working in the coal industry would think that, well, now oil will kill the coal industry, isn't it? This makes sense, right? If I'm working in the coal industry, it's very difficult, okay? It's not clean. It creates a lot of ash when you burn it, and it requires big machines because you need to burn the coal, and then you need to have water tanks that will have the water converted into steam, and then this steam will be converted into movable energy, right? So, and you see that there is now oil, and the oil can be let's say refined to some light product that is more efficient than coal. So if I was working on the coal industry in the 18th century, 19th century, I would say, well, oil will kill the coal industry, isn't it? So remember this analogy today, okay? Remember this analogy today. Fact, coal is until today being used, okay? Look into this nice picture. Coal consumption by region, and this is the number of years, okay? This is 1995, this is 2020, okay? Look into, of course, North America start to, by very harsh regulations, start to reduce dependency on coal. Similarly, Central America, Europe, I don't know what CIS is, Middle East and Africa, but Asia Pacific, especially China and India, they start to invest more and more in coal. And as a matter of fact, if you can look into all this energy increase by coal, this is huge, okay? So this is 2020, right? It's also very important to know that world historical and projected coal production between 1950 and 2050. So we are somewhere here today, okay? As you can see here, and I'm talking about coal here only, huh? Forget about wind, solar, or oil or gas. We're talking about coal, which is considered the most polluting energy resource, right? There is a huge dependency on coal in the coming 20 to 30 years, okay? And all that is projection, by the way, right? The main, I would say consumers will be China, India, and the US, and etc. Okay. Today, more than 6,500,000 people work in coal mining, processing, and delivery. Okay. There is also more than 2,500,000 people working in coal power generation and associated networks. This is a huge number. Okay. And look into this beautiful picture. Just look into the color, let's say, index or the color coding here. The white is closing mines. You don't see many whites here, right? Yellow is operating coal mines, all right? So as you can see here, these are, sorry, not coal mines, it's coal power plants, okay? Look into how many yellow, right, power plants are you know, motored by coal in the US. Look into the yellow dots here around the world. This color here is new. This is under construction, and this is planned. So this is planned, this is planned, this is under construction, and some of these are new here. So the message that I wanted to say here is that coal is there, and it will continue to be there. Okay. We also, what happened in the past year or several months, where when the wind energy became a problem in Europe, most of the European countries were forced to go and open the closed coal plants. Okay. Next, petroleum. So petroleum was a little bit new relatively new compared with coal. All right. In 1825, Imperial Russia produced 3,500 tons of oil and doubled its output by the mid-century, meaning around 1850. The first commercial oil well in Canada became operational in 1858, right? The first modern oil drill in the United States began in West Virginia and Pennsylvania in 1850s, okay? So really, we have to admit that the United States was I would say, the first country who really used the modern technology at that time, of course, to drill oil wells. By 1920s, oil fields had been established in many countries, including Canada, Poland, Sweden, Ukraine, United States, Peru, and Venezuela, and of course, in the Middle East around the 50s, okay, 40s, 50s, right? So when we talk about petroleum, it's not only about energy, okay? Petroleum has, you know, hundreds of products, okay? Yes, less than half of the petroleum is gasoline, which is used for cars. 26% is diesel and other fuels, and then 9% is jet fuels. And the rest, okay, almost 1/3, we're talking about lubricants, heavy fuel oils, asphalt, and other products. Other products such as, for example, adding dyes, detergents, lubricants, paraffin wax, scale wax, etc., asphaltene, and petrochemicals. Okay, so the need for oil and gas, or for petroleum, is not only for energy, it's for many of the products today. Polymers, plastics, all that are produced by basically by products of petroleum. Over 6,000 items are made from petroleum waste byproducts, including fertilizers, flooring, floor covering, perfumes, insecticides, I think it's for insects, to kill insects, petroleum jelly, soap, vitamins, and some essential amino acids. All that is coming from petroleum. The main countries that are producing gas as of, I think, 2020, we can see that the United States, okay, and then Russia, Iran, China, Canada, Qatar, Australia, and so on, okay? As you can see here, the natural gas production all around the world is also huge. Next, we start talking about nuclear, right? So everybody is now, when you hear about nuclear energy, everybody is scared. Why? Because the nuclear energy create nuclear waste, which is very dangerous, very poisonous, and can affect human health significantly. But how do we create? How do we use nuclear power to create energy? Basically, you take, for example, a radioactive material such as uranium-235. You add you excite it with a neutron, and then you have what we call the excited uranium, uranium المشع بالعربي. With excitation energy provided by kinetic energy of neutron plus the forces that bind the neutron. So you will need to excite this uranium, and then this uranium will split into two new atoms, or two new substances, krypton and barium, right? This split is what creates the energy. What is this energy? This energy is heat, right? So how does this work? Well, we have the, what we call it, the rod, the uranium rod. We excite this uranium rod, and then we let it split. Once it splits, it will create a lot of heat, huge amount of high temperature. Then what we do, to have a reactor vessel. This reactor vessel will have a circuit where it will generate steam. So it will go inside a water vessel. It will convert, because it has very high temperature, it will convert the water into steam, and then the steam will be taken to rotate turbines, and then the turbines will generate electricity. Then the water will be cooled again by a condenser, and then it will go again to the same reactor. So this is the cycle. What is the problem? The problem is that after this uranium rod is decayed, maybe after 10, 15 years, then it will not be useful to create enough energy or efficient energy to boil the water. Then it becomes what? Radioactive waste, because it will continue emitting radioactive rays until hundreds or thousands of years. That's why the only way to do that is by trying to contain this uranium waste or nuclear waste by putting it inside concrete and so on, and different layers, and then try to bury it somewhere. Of course, unfortunately, there are some third world countries who are full of corruption. They accept taking this nuclear waste from some of modern countries and bury it inside their soil, which is, of course, it may not show bad effects in the coming maybe 5 or 10 years, but of course, with time, definitely there will be a major effect. In 1954, the Obninsk nuclear power plant in Russia became the world's first nuclear power plant to generate electricity for a power grid. The world's first commercial nuclear power station in England was connected to the national power grid in 1956. Until today, there are nuclear reactors that are used to generate electricity. And by the way, in the 40s and 50s, it was expected that I saw a picture, I didn't bring it to the slide. It was expected that nuclear will become the main energy resource by far, right? But because after some incidents, let's say radioactive pollution, it was realized that, well, this may not be a very safe energy resource, and that's why the investment in nuclear start to become less and less. The major accident at a nuclear reactor occurred in 1961 at US Army Experimental Nuclear Power Reactor at Idaho National Laboratory, which killed 3 crew members. Another serious accident happened in 1968 on around the Soviet submarine K-27, resulted in 9 crew fatalities and 83 injuries. Okay. And this is the last picture for nuclear. Despite all the risks and environmental hazards, nuclear energy production remain growing year by year. Okay, so until 2020, we still have increase in nuclear consumption. In nuclear power as energy, mainly for electricity. Now we start talking about, so all these are the main energy resources. Now we start talking about renewable energy. Okay, clean energy, right? So obviously, what is renewable energy? Renewable energy is an energy that is available. The abundant of energy is available around us, mainly wind, water, etc. So the investment in wind energy became really significantly increasing around the 2000, okay? And within the last 25 years, many countries around the world start to invest in wind energy, okay? And we see that all around the world right now. Until 1920, more than 1,400 terawatt hour was generated by wind energy around the world, okay? This is a huge, and this is important, and this will continue to be the case. As you can imagine from this picture, we expect that during the coming 10, 30, 50 years, more and more wind energy will be created, right? However, one of the main problems, and this is one of the main, I would say, challenges, as you know, we're talking about challenges, right? Why we cannot easily, go take this transition quickly. Number one is the cost, okay? Each average wind turbine, we're not talking about, there are larger wind turbines, but we're talking about the average wind turbines. It costs between 2.6 to 4 million per turbine, US dollars, okay? So each turbine costs between 2.6 to 4 million dollars. Of course, it can be higher with the larger, and it differs between, of course, onshore and offshore. What does that mean? It means that in order for any country to invest in wind energy, suppose that they need to create, for example, 100 wind turbines. You multiply this number by 100, and this is a huge cost. The issue is that the return of investment is very slow, okay? The amount of energy or the amount of electricity that will come out of these wind turbines, yes, it is I would say clean, yes, it is renewable, but the problem is it will need probably something like 15 years, okay, for return of investment. And guess what will happen after 15 years? These wind turbines will need to be replaced. And the problem is the maintenance. Those are movable parts, right? It always rotates, and we're talking about gears. We're talking about steel that rotates. It needs maintenance. It needs lubrication, etc. Okay, the cost is 1.3 million per megawatt. Okay. So if you can do the math, this is not, I would say, profitable for private companies, and that's why it's a must on countries or authorities to subsidize this business. Otherwise, it's a lost business. Okay, the countries need to invest in order for this type of energy to become alive. Otherwise, it is not profitable. Okay. Most commercial wind turbines have a capacity of 2 to 3 megawatt, but offshore turbines can be as large as 12 megawatt. Wind turbine maintenance cost, once built, maintenance is an ongoing expense. It requires 1 to 2 cents per kilowatt hour produced, or 42,000 to 48,000 per year. So every year it will cost to maintain one wind power around, let's say in the middle, $45,000 per wind turbine. Okay. There is also a sad fact, unfortunately, about wind turbines, is that wind turbines kill birds. Maybe it's a surprise, but it is a fact and it is documented. The US Fish and Wildlife Service estimates that between 140,000 and 500,000 bird deaths occurs at wind farms every year. Wind turbines have also been found to be one of the leading causes of mass bat mortalities, with some studies pinning fatalities at 888,000 bats every year. Why is that? Well, the idea is pretty simple. Where do you think engineers would plant or would install these wind turbines? Well, they study the wind currents. Okay, they have sensors. They study the wind currents. So the wind currents or the wind around the globe are usually move in almost fixed paths, right? So you go to the area where wind has the highest capacity, and then you install these wind turbines. But these wind paths are also used by birds, especially migrating birds, because it will help them fly with the lowest energy, right? So you are actually installing these wind turbines on their way, and that's why it causes thousands of bird fatalities. Okay. Finally, wind turbines cannot be recycled, or at least today, right? I heard that there is a new production of wind turbines that can be recycled, but it's very expensive. And these are basically alloys between aluminum and plastics and so on. And once they go out of end of their life in maybe 10, 15 years, you have to bury them. And this is, of course, an environmental risk. Okay. So this is another challenge of the wind energy. Okay. Let's move on. What do we have? Hydropower water. Okay. Dams. Now everybody, especially in the Nile, is talking about Ethiopia and the dams they're building, and Sudan and Egypt. And this, of course, can create a major problem. But without talking about politics, hydropower is a very, very important source of energy. Okay, it is very stable and it can create electricity for tens, if not hundreds of years. Okay. And it's used in many countries around the world where it is suitable. Okay. The way it works is that you have a reservoir, and then this reservoir will have a channel. This channel will have a water path. This water path will rotate the turbine, and the turbine will create the energy. Okay. Now, what are the advantages of hydropower or water power? Number one, it is flexibility. So you can install small or big dams. Low cost and high value power. Suitability for industrial applications. It has zero CO2 emissions, of course, and other uses of the reservoir. You can use the reservoir for other purposes. The problems or the limitations of hydropower is that highly affected by seasonal rain levels. Okay. You go into some of the countries in the Middle East, maybe Jordan, Lebanon, Syria, and some of the also North Africa countries, and some countries in the East, such as India and so on, and you will find if not hundreds, tens of dams that are just built there without any water because the water has evaporated. So it really depends on seasonal rain levels. If you don't have enough seasonal rain levels, then you don't have energy, basically. And it's pretty simple. In Africa, they are a bit lucky because they have a river. And if there's a river, then the river is strong, then you have more sustainable energy. But if you put your dams around, between mountains where you just wait until the rain comes and then it will fill the tank, then you're in danger because many years it may not rain enough. Okay, it has ecosystem and damage and loss of land, of course, because you will need to fill the tank, and once you fill the tank, it will take a lot of the surrounding areas. Water loss by evaporation, siltation and flow shortage, and methane emissions from the reservoir, and of course failure risks. And we saw some of the catastrophes where the water dam falls down basically. However, and in my opinion, one of the main limitations is that you cannot install it everywhere. You will have to have a very, I would say, convenient structure in order for you to be able to get benefit out of the hydropower. I live in Norway, for example. Norway is very, I would say, lucky country because there are a lot of course, water resources, and almost 90% of the electricity in Norway is generated by hydropower, which is, of course, great. Solar power. This is the second most important renewable energy. Solar power is the conversion of the energy from sunlight into electricity. Okay, we have two methods. Either we use what we call the photovoltaic cells, or indirectly using concentrated solar power. What do we mean? The photovoltaic solar cells are basically a manufactured material that will automatically, once it has solar radiation, it will generate electricity by itself. Okay, so photovoltaic cells convert light into electric current using photovoltaic effect, right? However, the efficiency of the photovoltaic solar systems maximum can reach up to probably 14–15%, and it can go significantly lower depending on the quality of the material and if there is any dust or some kind of anything covering these solar panels. And it can be also electricity, the solar energy can be used indirectly by basically having mirrors. These mirrors will concentrate the solar energy coming from sun into water, into I would say water tubes. These water tubes will boil, and then it will convert it into steam, and then the steam will rotate the turbines. Okay. There are many concentrated solar powers around the world, and there are different, I would say, mechanisms for concentrating this power. You can find, for example, a big pole that has the water system on the top, and then you have on the ground many mirrors that will move automatically to concentrate the solar energy into that water pole. What is the problem with solar energy? What is the challenge of solar energy? Number one, it's again return of investment. It's very expensive. Of course, less expensive than wind energy. And nowadays, we found that a lot of companies are creating solar panels with cheaper prices. And unfortunately, the efficiency is not as good. So you have to be careful because there are many third world countries who bought some of these cheap solar panels, and they were not worth it. They were basically not generating enough electricity. The efficiency can be as low as 7 or 6 or 5%. Number two, it is water. It is weather dependent. You have to have, sun in the you know, in the sky, right? In the Middle East and Africa, this is no problem. Okay, so I think solar is a very good investment here, right? Number two, the problem is the storage. Okay, the storage is very expensive. You will need to, you know, scientists need to invest new methods for making batteries less expensive. Okay, requires a lot of space, of course, and it is of course associated with pollution, because in order, once you know, the solar panels are out of use, you have to expose them, and it's highly polluting. The quality can degrade with time. I mean, within 5, 6, 7 years, the solar panels start to come less and less efficient, and requires, of course, continuous cleaning. As you can see here, you know, just a small layer of dust will reduce the capacity and will reduce the efficiency big time. For example, if you have hail, the hail can destroy the water panels within minutes. Okay, so it's a little bit fragile. So that's why there are some concerns here. The last source of renewable energy is geothermal. So what is geothermal? Geothermal is to get use of the high temperature in the ground, okay, on Earth. So there are two forms. The first form is basically to inject water into a already hot water source around, you know, and maybe in 50 or 100 or 200 or maybe 500 meters, and then you produce the hot water. This hot water by itself will be in a form of steam that will rotate the turbines. And of course, this is not very, I would say, easy to find, because you will find, you need to find very, I would say, special conditions to find these water reservoirs. Okay. Or you can have, for example, the production well, you have a hot pressurized and with CO2, and then you can have CO2 turbine, okay, and then you can inject the CO2 back. So again, geothermal is good enough, but it's not, I would say, very commonly available. Of course, when we talk about, it started around 19, so it's not something new. But steam and hot water from the geysers, it's called, began heating homes in Iceland starting in 1943. And as you can see here, these are the main countries that use geothermal. It's renewable, sustainable, but Earth can carry a mixture of gases such as CO2, H2S, methane, and NH3. Hot water may hold a solution traces of toxic elements such as mercury, boron, or antimony. Drilling geothermal wells is more expensive than drilling oil wells of the comparable depth. And this is because it's a different environment and requires special handling. With that, where do we stand today? So as I saw in my previous slides, I talked about the different energy resources, okay? We talked about the main energy resources such as coal, petroleum, gas, you know, nuclear, etc. And then we talked about the renewable energy resources, wind, solar, and geothermal, etc. However, we all realize that global warming is real, right? This picture is a very worrying picture. Around, you know, in the 19th century or the 20th century, the temperature was the global temperature was actually below the average, and then with time you can see that around 1980, okay, the global temperature start to rise significantly, and now we're talking about 1 degree Celsius increase every year, okay, and this continues to rise. This also was accompanied with the rise of global carbon dioxide concentration. So what is the relationship between carbon dioxide and global warming? Well, basically, the theory says that the CO2 has some properties that will work as a blanket, that will basically absorb the reflected solar energy on Earth. So, for example, you have the solar energy coming from sun, and then the CO2 will start to absorb this energy, and then it will remain in the atmosphere, which is creating the global warming issues. Okay, so what do we do? Well, many people can easily say, let's stop fossil fuel. And you see that a lot of environmentalists, they are trying to take, all measures. We also that, last year there was the GOP, I think, or 26, where all the global leaders around the world agreed to have zero emissions target by 2050. Okay, so where do we stand as oil and gas professionals? Okay, number one, we have to realize that this is a fact, and we have to realize that yes, fossil fuels create more CO2. This is a fact. We cannot deny that. But is it really practical to eliminate fossil fuel and rely mainly on renewables? Well, this picture tells you the answer. The problem is that the world needs more energy. The population, the global population is increasing every year, right? And more people means more need for energy. Look into this picture. So this is a picture of the primary energy consumption by source. This is oil, this is coal, and this is gas. And as you can see here, this is everything else: hydropower, nuclear, wind, solar, biofuels. Okay. What does this mean? It means that today, the hydrocarbon, the fossil fuels, the coal, oil, and gas are still the main contributor to the energy mix around the world. Okay. What will happen in the coming 50 years or 30 years? Well, there will be more need for energy. So what do? We encourage investing in more renewable energies, but it will not be enough to feed the hunger of the energy in the world. Okay. Look into this picture, for example. This is just a comparison of almost 30 years between 1990 and 2019. Okay, the coal consumption increased, gas consumption increased, and then this is the renewables. All right, so we need more energy, but it is not energy transition that what's happening in the coming 30 years. It is energy mix, right? This is another very famous picture. Okay. This is by 2019, and all what I'm showing here is documented. I put the resources here. Okay, this is 2019. This is coal. This is oil. This is gas, nuclear, and then renewable and others. So as of today, we can easily say that probably 60% of the global energy mix is coming from fossil fuels, and this will remain for many years to come. This picture here is from the BP Energy Outlook, right? Look into the increase until 2040. So we're talking about 20 years from now. This is how the global energy need will look like. And of course, oil, gas, and coal will remain a very basic component of energy mix. Okay? What does that mean? It means that there will be still future need for petroleum engineers. So you don't need to worry. the percentage of energy from oil and natural gas the world needs is expected to decline from about 53% to about 48% over the next 30 years. I will repeat the sentence. The percentage of energy from oil and natural gas the world needs is expected to decline from 53 to 48%. This is the percentage over the next 30 years. The amount of production is expected to increase by 20% for oil and 50% for natural gas. Why is that? Because, as I said, the world needs more energy. So yes, the mix will change, meaning the oil and gas portion from the global energy will start to become less, but the need for the oil and gas itself must increase in order for the energy mix to be sustainable. This is due to mainly to the expected increase in the world population from 7.5 million to 9 billion. Sorry, 7.5 billion to 9 billion, and improvements in the economic conditions of developing countries. Climate change is real. We should transform our industry in every possible way to minimize any adverse effects of our work on the environment and to comply with state regulations. With the recent developments in data science and engineering analytics, there is a greater need for petroleum engineers with an understanding of physics to take advantage of these improvements and optimize the processes we use. And finally, I'd like to end with this slide. New skills needed for petroleum engineers. You as petroleum engineers, you will need to learn new skills in order to be equipped with the tools that you'll find a job easily, and then to contribute to the environmental obligations. Number one, programming, data science, and machine learning. And everything now is available online. You can learn a lot of programming, Python, data mining, machine learning, etc., all that available for free online. Learn more about CO2, capture, phase behavior, transport, and downhole storage. Learn more about H2, hydrogen, production, phase behavior, transport, and storage. Geothermal energy, exploration, drilling, and modeling. This is an area under petroleum engineering. Environmental consideration of drilling fluids, cuttings, and waste management, flare management. And finally, try to find middle ground between oil and gas and renewables. Who knows? Maybe we can have, let's say, a wind turbine that will operate a rig, right? Or operate a data sensor for a platform, etc. With that, I'd like to thank you all, and I'm glad for being here today. It's almost an hour now, so let's open the questions. Thank you very much.
Hello, thank you, Mr. Ahmed, for this informative presentation. I just want you to reorder the energy mix as from efficiency point of view. Which one is efficient? Is it wind, for example, efficient, or solar energy efficient? So this is what I mean. So if you could please.
Yeah. So that's a difficult question because, for example, I mean, the wind turbine is different from solar panel, different from let's say gasoline. The reason is we cannot talk about the wind turbine in terms of energy, in terms of efficiency, but what we can talk about in wind power is, for example, the return of investment, because as I said, this is the main problem, and the durability of the wind power, for example. That's why efficiency doesn't play a major role in classifying wind energy. Okay, so as I said, wind turbines are not profitable business. It has to be subsidized by governments. Okay, but it is sustainable. It can produce energy for many years. But then, of course, there is the running cost, there is the initial cost, okay, and there's the maintenance, and then what do you do after 15 years when these wind turbines will be expired? When it comes to solar, solar has probably one of the lowest efficiency, but it is cheap. It is, I would say, free, because you're just put it on an open area, and it is coming from the sun. So we are not putting anything after we install these solar panels. Okay, the gasoline, for example. Imagine that if I'm 20 years, 200 years ago, and I tell you that with this amount of gasoline liquid, right, you can make a car that weighs 2 tons to drive for 10 kilometers. You will not believe me, okay? This is very, very efficient, right? But then in order for you to reach into the extraction of gasoline, that's a long cycle. So I don't think it's the efficiency, but it's the very different elements that will contribute to each other. As I said, there is nothing bad or good about energy resources. Definitely, clean energy is the most profitable or preferable, because it doesn't have but it has much lower environmental impact. However, it's not enough. We need more energy. So there is the hope, and there's the practical aspect of things. Okay. Let's see questions from the chat. All right. Excuse me, my name is Rabika Gallery from Indonesia. I study IT. Okay. Does this webinar have certificate benefit? Because I really I'm not sure it's certified, but you can talk to the PetroNile team for that. Okay, I'm consultant in reservoir engineering. Good presentation. I think that geothermal is also expensive. I think the solar energy is better, is widely used, and respect environment, no CO2 emissions, and pollute atmosphere. I agree. It is very useful. But as I said, it's a bit fragile, and it can break easily. You have to clean it, because once dust or I remember, there was some solar panels around one country in Europe, and it was filled with snow, so it produced zero electricity, and it works in countries where the day is especially around the equator, around the Middle East and so on. Yes, very, very efficient, very useful. My name, okay, all right, no problem. Okay. We should change our titles to energy engineers. Well, I don't know. I would say that I'm proud petroleum engineer. So as the coal engineers, but it's up to you. You can call yourself whatever you want. Any more questions? Okay. More insight about transfer of the technology to third world countries to reduce climate change, roles of oil big companies in the transition of the climate change. That's a good question. So I think we have to always encourage all the renewable energy projects and try to make it cheaper in order for the energy to reach into many of the third world countries and the poor countries who cannot afford, to buy expensive electricity. And this is one of the things that I wanted to say when I say that the world needs more energy. This is a fact. Okay, as of today, many countries around Africa, around Asia, Latin America, and so on. Sometimes 50-60% of the population don't have access to electricity. What does that mean? It means that the electricity is expensive. Otherwise, the country can easily provide electricity to the people, right? And by having, and this is an example where it's no one-man show. You cannot really say that I have to remove hydrocarbon, fossil fuels, and rely on renewable energy. It doesn't work. All right. The people around the world need energy, need electricity. And by investing in renewable energy, such as solar, wind power, etc., dams and hydropower, this will, and when this energy resources are becoming cheaper and cheaper, this will make more poor countries have access to the electricity, which is, of course, a basic need right now in our life. Roles of big oil companies in the transition and climate change. Yes, this is happening today. Almost all the big players, including Schlumberger, for example, I work for Schlumberger, Shell, BP, etc., are considering new energy. They call it new energy, and they're considering, for example, how can we contribute to that? For example, in my specialty, where I am PIPESIM Product Champion, and we have another product called Olga for flow assurance. We are now exposing how we can use our software in CO2 transport, for example, and then coupled with the reservoir simulation for CO2 injection in the reservoir. So all that is being considered. As I said, all the big players are now considering that, and they are even committing to the zero emissions. When we say that by 2050 we will have zero CO2 emissions, that does not mean we will not produce CO2, but it means that when the machine produces the CO2, we will need to capture that CO2 and use it somehow, either store it, either inject it in the reservoir, etc. Okay. Then, okay, what is your projections of future of energy, knowing history isn't linear, and what's going to on now globally? Well, of course, as you said, I mean, no one can really predict what will happen in the future. What I think will happen, at least in the coming future, there will be more investment into renewables. There will be more restrictions on hydrocarbons. But if the world needs to sustain the level of life that we have today, transportation, cars, electricity, etc., it is not practical to put more restrictions on hydrocarbon. Good example is what happened with the U.S. government right now. So President Biden, when he was elected, one of his promises was to actually restrict and put more pressure on the oil and gas industry. Now, in this crisis, when it happened political crisis with Russia and so on, although U.S. has a lot of oil production, Biden wanted the Middle East to pump more. And this is a good example of, this is not practical, guys. We have to, yes, we will need to invest more in renewable energy. We will need to find more ways to capture CO2, to make our industry more environmentally friendly, but we cannot say that we can just simply stop the investment in oil and gas business. What will happen when fossil energy ends? When will that happen? Nobody knows, by the way. I mean, every year, countries discover new fields, right? So, I mean, we don't know when exactly this is going to happen. But if, for example, we say that, well, the fossil fuel will end in 200 years, for example, we hope that by 200 years, we will have efficient energy resources that will maintain our life. Otherwise, we're in a big problem. Again, thank you for an informative question. Currently, many countries, oil companies, talk about unconventional hydrocarbon resources, and unconventional conventional will reduce more CO2 or less. Well, unconventional is nothing but tight reservoirs. Okay, so unconventionals. So what's the difference between conventional and unconventional? The conventional reservoir, you have oil or gas, with high permeability, you drill the well, the oil or gas comes easily. Unconventional, it's a very tight rock that has very, very small permeability. It has a lot of oil or gas, but you drill, hydrocarbon will not come. So you need to frack. You need to crack it hydraulically. And that's why you inject a lot of, liquids and special material to literally crack the formation, to crack the rocks. And then the oil or gas start to come. This is basically what unconventional resources is. So this is the unconventional reservoirs, okay? It is nothing but rich reservoirs that have low permeability, and then you crack them to produce the oil. Of course, it has environmental impact because you are injecting chemicals and other material to the shale formations, and this might go up to the to agricultural life and so on. So it's not about CO2, it's about the environmental consideration during the drilling operation. What is the best type of renewable energy? That's a good question, and there is no answer, to be honest, because as I said, everyone has its own pros and cons. Some solar is cheaper. You can install it around your house, for example. Wind is, I would say, more sustainable because wind can blow day and night. Solar only, works during day. So, I mean, there is really nothing. Again, guys, let's not talk about the energy resource or the energy source. Let's talk about the energy mix. And this is what the world needs now. So all of us, we as oil and gas professionals, our colleagues in geothermal, our colleagues in the coal mining, and then our colleagues in the renewable energy business, all of us are working together to make this, to make the life on Earth much easier, okay? Equal theory and its limitations and how reflective it's on hydrocarbon reserves globally, reality with demand and supply. Again, peak oil is a term that is not very well defined, okay? Because, as I said, every year we find countries that are finding new reservoirs. There are countries today, I'll give you an example. Look into a country like Venezuela. It has the highest oil reserves in the whole world, but it's not producing anything because of the corruption and because of the politics, the bad politics in Venezuela, right? You see, for example, countries where it has heavy oil. How do we classify that? There are countries that are exploring now and finding new oil and gas reserves. So peak oil is something that is a little bit not very well defined. So that's why, as I said before, you don't know when oil and gas will be gone completely. Okay, I think we've taken now about more than 15 minutes on questions. I'd like to thank you all. I'd like to thank the team in PetroNile Academy for arranging this event. And it was a pleasure being with you this evening. Thank you very much, and wish to see you at another event.
Thank you, Mr. Ahmed. We highly appreciate your existence. And let me say that it was a very nice session. It's very informative. And I want to comment and I want to emphasize actually the tips that you are say to the fresh graduate. They have to work hard in themselves and trying to acquire all knowledge together so they can position themselves post in oil and gas and renewable industry. So they've got to work on this. So I highly like this point. Again, thank you everyone. Thank you for being here with us. Don't forget to subscribe our channel, YouTube channel, and our other platforms, on Facebook and Twitter and so on, events. Bye-bye. Thank you, Mr. Ahmed.
Thank you. Bye.
Bye.